the rate measure topic is actually excluded in the CBSE syllabus. I don't know whether it will be included or whether it will be excluded from the state syllabus. That's why timely 1, 2, 3 problems were there in rate measure. I will halt it, and even one more section in application of differentiation, that is approximation, is also removed from the CBSE syllabus for this year. That's why let us take, after the state syllabus is released, let us think about those two sections. Okay. Now coming to the one more section of application of differentiation, increasing and decreasing function. Okay. Increasing and decreasing function. 1 3 marks question is sure on this particular section. Increasing and decreasing function. Okay. Timing, let us try to understand what we mean by increasing function and what we mean by decreasing function. Okay. So for problem solution point of view, a different formula is there, but try to understand what is increasing function and what is decreasing function. A function, look here, a function f of x is said to be increasing function, is said to be an increasing function, in an interval, interval is the subset of real numbers. No, it is a set. Interval is a set. In an interval R I is equals to A to B, I is equals to A to B. Okay. If x1 comma x2 belongs to I, f of x1 is greater than or equals to f of x2. Okay. F of x1 is greater than or equals to f of x2. x1 and x2 belongs to an interval I, then f of x1 should be greater than or equals to f of x2. F of x1 value is greater than or equals to f of x2 value. The graph of the value of the function, if x1 is, x1 and x2, x1 is greater than or x2, x1 is greater than x2, then f of x1 is greater than or equals to f of x2 for all x1, x2 belongs to R. Okay. If x1 value is greater than x2, but f of x1 value is also greater than or even equals to f2. Okay. So for example, look here, the graph will be like this. x1 is greater than x2. x1 is greater than x2, then f of x1 is also greater than f of x2. For example, look here, f of x is equals to sin x. 30 degree is 60 degree is greater than what? 30 degrees. Okay, let us take the interval x belongs to 0 to 90. Okay, the interval is 0 to 90. 60 degree is greater than 30 degree. What is f of 60 degree? F of 60 degree is 3 by 2. And what is the f of 60 degree? 30 degrees, sin 30. F of 30 means sin 30. Sin 30 is half. Definitely, f of 60 is greater than or equals to f of 30. Is it not? So 30 by 2 is greater than, either it should be greater than or it should be equals to, for simply increasing. Okay. Therefore, so f of x is equals to sin x is an increasing function in the interval 0 to 90. So 3 by 2, root 3 by 2, I'm sorry, f of 60 is root 3 by 2. F of 60 is, f of 60 sin 60 is root 3 upon 2. But root 3 upon 2 is somewhat 0.86. Half is 0.5. 0.86 is definitely greater than 0.5. Okay, therefore f of 60 is greater than or even equals greater than or equals to. Anyone holds good enough. Greater than is that, that's also enough. Equals to is that, then also enough. So the graph of increasing function will be like this, It may be flat somewhere and it may be like this. So here is x1 and here is x2. The graph may be even flattened out, may be flattened out at some particular point. Okay, so like this. Here it is x1, suppose here is x2. On x-axis it is y. Y means f of x. Y is equals to f of x. Okay. F of x is taken here. So it is f of x1 value. This is x2 set, this is x1. Here x1 is bigger than x2. Okay. x1 is bigger than x2. Right side is bigger. No? Here f of x2 value. Here comes the f of x1 value. So for f of x1, this is bigger than, on the number like 0, 1, 2, 3, automatically more is the height, more is the value of y, means f of x. Y is equal to f of x. Always function y can be called as, f of x can be called as y. Therefore here x1 is bigger than x2, automatically f of x1 is also bigger than f of x2, therefore the function is what? Increasing one. Here is flattened out. Here actually for this particular portion, this is x1, this is x2. So, this is x2, this is x1. Here x1 is bigger than x2, but f of x1 and f of x2 are equal because equals force f of x1 for increasing function. F of x1 may be even equals to x2 also. Even here x1 is greater than x2 here. x1 is here, x2 is here. On the number line it is 0, it is 2, it is 4, it is 6. 6 is greater than 4. But f of x1 and f of x2 are same. Even equals to also is possible. Therefore, this is the graph of increasing function. Graph of increasing function. This is the graph of, just try for the sake of understanding increasing and decreasing function I will explain with the help of the graph. Actually, the problem solution, a derivative formula is there. Let us take it later on. Graph of increasing function. Okay. Increasing function. A function f of x is said to be strictly increasing function in the interval. A function, simply I will write f, is said to be strictly increasing. Exam point of view, this graph are not necessary, but you have to understand the theories. No, without understanding the theories, simply only exam point of view theories are taken, then without basics. So you can't remember the things. CET sake also, that's not good. A function f is said to be strictly increasing. The word strictly is there. Increasing. In whenever strictly there, take the open interval. Okay. In strictly is the open interval. And simply increasing is there, you can take closed interval. In a to b, these are the values of x. X belongs to this interval. Okay. In open interval a to b, this a to b, x takes the value, here is a, here is b, x takes the value from a to b like that. Okay. X take a is 4, b is 10 set, increasing in 4 to 10. Just for example, sin f of x is sin x. I have taken the interval 0 to 90 degrees. A is 0, b is 90 degrees. So x takes any value in between 0 to 90. This is the interval for x. X can take any value in between a to b. Open interval. Open interval means the boundary values will not be taken by x. Closed interval means the boundary values also can be taken by x and in between values can be taken by x. In both open as well as closed. Closed means square bracket. Open means round bracket. The x can take here only in between values of a and b, and here x can take in between values as well as closed interval boundary values. In simply strictly increasing, you have to take open interval. Increasing a to b, if x1 x2 belongs to, so if x1 is greater than x2, if then f of x1 is strictly increasing. So this is the inequality, strict inequality. Okay, equals to is not that f of x1 is greater than f of x2. F of x1 is greater than what? F of x2. For all x1 comma x2 belongs to what? The open interval. But strictly you take the open interval. Okay. For simply increasing, you take the closed interval. So f of x1 is greater than, equals to chance, equals to f of x1 is equals to f of x2 should not be there. Strictly increasing, f of x1 is greater than f of x2 for all x1, x2, comma x2 belongs to a to b. Means x1 and x2 may be any values of the interval a to b. So the graph is like this. The graph is strictly increasing. The graph will be like this. Okay. So it is f of x, on y-axis f of x is taken, and here it is x values are taken on x-axis. Okay. In the simply increasing, the graph may be flattened out, but strictly increasing, no question of flattening out the graph is, but it is heading upwards only. Okay. So third one, it is the first one. This is the second one. This is the third one. A function f is said to be, f of x is said to be and decreasing function. When decreasing function is there, you take the closed interval. Increasing function is there, you take the open interval. Decreasing function in the interval. In the interval, closed interval a to b, in a particular interval, the function graph is upward. In a particular interval, the graph is downwards. Upward means increasing, downwards means decreasing. In an interval a to b, if x1 is greater than x2, then f of x1 is less than or equals to f of x2. Okay. Even though x1 is bigger than x2, but f of x1 value is smaller than or equals to f of x2. The graph of decreasing function is as below. Here is y-axis, here is x-axis, on x-axis x values are taken, on y-axis f of x values are taken, because y means f of x. Here is x1, here is x2, here is x1 is bigger than x2, is it not? x1 is in the right side of x2 means as you go rightwards, the value increases 0, 1, 2, 3, 4, 5 like that. Therefore, x1 is right of x2 means x1 is bigger than x2 here. So, but look at the graph. So, this is the f of x1 value, this is the f of x2 value. Here comes f of x2. And here comes f of x1. Which one is bigger here? F of x2 is above, f of x1 is below. Therefore, f of x1 is, but it is smaller than f of x2. Even though x1 is bigger than x2, f of x1 is y. Y is equals to f of x. So, f of x1 is smaller than f of x2. That is the nature of decreasing function. Decreasing function curve is heading downwards. Increasing function curve is heading outwards. Now f of x is, but it is graph of increasing function, it is graph of decreasing function. It is the graph of strictly increasing function, graph of strictly increasing function. I will put the increasing as upward arrow mark, hence onwards increasing. To shorten the writing, I will take upward arrow mark as an increasing, downward arrow mark as decreasing. So, strictly increasing function. Okay. Graph of strictly increasing function is graph of increasing function. So decreasing function is graph of decreasing function. Decreasing is equal to the downward arrow mark. Okay. Decreasing, downward arrow mark, hence onwards. Okay. Increasing means upward arrow. Upward. Now strictly, same, let us say a function f is said to be strictly decreasing function, strictly. Coming to the fourth a function f of x is said to be an strictly decreasing function. Said to be fourth one, strictly decreasing function. Decreasing function in x belongs to the open interval a to b. For strictly decreasing, you take the open interval. For increasing, simply increasing or decreasing, you take the closed interval. If x1 is greater than x2, then f of x1 is greater than, here it is greater than or equals to is there. No. F of x1 is less than or equals to f of x2, less than. Here less than or equals to. Even though x1 is greater than x2, f of x1 is smaller than f of x2, smaller than or equals to for increasing. For strictly increasing, f of x1 is less than, equals to is not there. Okay? Because this is strict inequality. Last year I studied. It is strict inequality, less than. Strict inequality. Less than or equals to or greater than or equals to is called as simply increasing and decreasing. Hello? It is strictly increasing, greater, strictly greater. Strictly lesser, strictly greater. It is simply lesser or equals to, greater or equals to, not strictly. Therefore, for strictly, only lesser than or greater than symbol should be used, not equals to. Okay, that's the difference. Only difference between the increasing or decreasing. For strictly increasing, open interval a to b should be taken. For increasing or decreasing, closed interval a to b is to be taken. Okay. F of x1 for all x1, x2 belongs to the open interval a to b. Okay. Now, if a function is in an interval, increases in some portion and decreases in some portion, then the function is said to be neither increasing nor decreasing in the interval. So, fifth one, so strictly decreasing, let's draw the graph. This is the graph of f is strictly decreasing. This is x values, and here it is f of x values. On y-axis, f of x values is taken. If the graph is strictly heading downwards, f is strictly decreasing. Understood? For strictly decreasing, less than f of x1 is greater than, or f of x1 is less than f of x2 will be there, equals to what comes. For strictly increasing, open interval should be taken. For simply increasing and decreasing, f of x1 is greater than or equals to, less than or equals to comes. Okay, and f of, for strictly decreasing or increasing or decreasing, x belongs to the open interval a to b should be taken. Okay, f is strictly decreasing function. Fifth one, a function is said to be neither increasing, is said to be neither increasing nor decreasing. Neither increasing nor decreasing in an interval. In an interval, x belongs to AB. If x belongs to AB, if f of x is increasing in some portion and f of x is decreasing in some portion. If f of x is increasing as well as decreasing in the subinterval of AB. In the subinterval of AB. Okay, what do you mean by that? With the help of the graph, I will tell you. Means in some portion it is increasing in the interval A to B, some portion it is increasing and some portion it is decreasing. Neither following the strict nature of either increasing or decreasing in the whole interval A to B. In some portion it is increasing, some portion it is in the interval of A to B. In some portion it is increasing, some portion it is decreasing. Then the graph, then the function is said to be neither increasing nor decreasing. Okay. Look here. For example, let us take the graph. The graph is the idea. Let us take the sine curve. Sine curve 0, pi by 2 and pi. Look at the sine curve 0 to pi by 2 increasing. Pi by 2 to pi, it is decreasing. Pi by 2 minus 3 pi by 2, it is minus 1. You know that sin x is plus 1, y equals to sin x. Just take one. And sin pi is what? 0. Sin 2 pi is what? 0. Okay. Sin pi by 2 is plus 1. Sin 3 pi by 2 is minus 1. So, in the interval 0 to pi by 2, sin x is strictly increasing. In the interval pi by 2 to pi, it is strictly pi by 2 to even 3 pi by 2, up to 3 pi by 2, you can nature of the curve, strictly decreasing. And in the interval 0, 3 pi by 2 to 2 pi, it is strictly increasing. But the interval 0 to pi is concerned, somewhere it is increasing, somewhere it is decreasing. So, in the interval 0 to pi, I am talking about 0 to pi, strictly 0 to pi by 2 is taken, sin x is strictly increasing. And pi by 2 to pi is taken, the function is strictly decreasing. Even pi by 2 to 3 pi by 2. Okay. Sin 3 pi by 2 is minus 1, sin pi by 2 is 1, sin pi is 0, sin 2 pi is also 0, sin n pi is 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi are 0, y equals to sin x. Therefore, sin pi by 2 is 1, when x is pi by 2, y is 1. Therefore, here comes the point, pi by 2 and 1. When x is pi by pi, y is 0, because sin pi is 0, therefore here comes the point, pi and 0. When x is 3 pi by 2, y is sin pi by 3 pi by 2 is minus 1, therefore y is minus 1, here comes the point, 3 pi by 2 and minus 1. X is 3 pi by 2 and y is minus 1. Here comes the point, x is pi by 2, y is 1, y is sin x, sin pi by 2 is 1. So, in the interval 0 to pi by 2 it is strictly increasing. Pi by 2 to 3 pi by 2 is strictly decreasing. But in the interval 0 to pi is taken, some portion it is increasing, 0 to pi by 2 increasing, and 0 to pi by 2 to pi it is decreasing. Therefore, it is neither increasing or not decreasing in 0 to pi. So, the function y equals to sin x is neither increasing nor decreasing. Neither increasing or neither increasing nor decreasing. In 0 to pi. Okay. In the interval 0 to pi. Let us take open interval. So 0 to pi. Okay. Because somewhere it is increasing in the interval 0 to pi. The subinterval is 0 to pi by 1 subinterval. In that subinterval it is increasing. And another subinterval of 0 to pi is pi by 2 to pi. It is decreasing there. Therefore, some portion, in some subinterval it is increasing, some subinterval it is decreasing. In the whole interval of a to b, then it is neither increasing nor decreasing. It is a, this is b I have taken. Okay, a to b. A is 0 here, and b is pi. In the interval a to b means 0 to pi. So, some portion 0 to pi by 2 is increasing and pi by 2 to pi it is decreasing. Unique nature is not there. Therefore, it is neither increasing nor decreasing. Now, let us come into the definition of what it is. Mathematical derivative definition for increasing and decreasing function. Let us take the main definition of this section. Okay, of this section. 5 minutes is that. So let us take the f is let. Just remember the formula enough. This definition is not necessary. Application of differentiation. Not any definitions are not necessary. Important from the examination point of view, but problem solution point of view is necessary. Okay. Let f is definition. Let f be a continuous on. Let f be a continuous function on. Continuous function on the interval, closed interval A to B, continuity is on the closed interval and differentiability is on the open interval. And differentiable on the open interval, A to B, then F is strictly increasing in open interval A to B. In textbook is given as closed interval, but it is wrong. It is open interval A to B. If f dash of x means dy by dx. F dash of x means by entitlement dy by dx. Okay. F dash of x is greater than 0 for each x belongs to the open interval A to B. For each x, first order derivative dy by dx should be strictly greater than 0. Then the function is said to be for all x belongs to the open interval A to B. X may be any angle through any value in between A to B because open interval is taken now. If f dash of x, first order derivative for those x values where x values are any value in between A and B should be positive. F dash of x should be positive. Or means dy by dx should be positive. If f dash of x is positive, then the function is increasing. If dash of x is negative, then f is decreasing. That is the main definition. Okay. B, f is said to be f is strictly decreasing in the open interval A to B if f dash of x is less than 0, strictly less than 0 for each x belongs to A to B, open interval A to B. Okay, this is the main definition. So, f is constant function. F is said to be a constant function. Constant function in A to B if f dash of x means dy by dx is equals to 0 for each x belongs to the open interval A to B. Okay. So for strictly increasing, f dash of x should be positive, and for strictly decreasing, f dash of x should be negative. Less than 0 means negative, greater than 0 means positive. For all x belong to the interval A to B, open interval A to B, if f dash of x is always a positive number, then f of x is said to be strictly increasing. If for all x belongs to the open interval A to B, if f dash of x is always a negative number, then f is said to be a decreasing function. F dash of x is always equal to 0 for all x belongs to A to B, then f of x is a constant function. Okay, this is the main definition of increasing function with help of derivative. F dash of x means you have to work out f dash of x. In that interval, you have to see whether it is in positive, f dash of x is positive, or f dash of x is negative in that interval. In that interval means for the values of x belongs to that interval. 3 to 5 means x can be taken as 3.1 or 3.2 or 4.99. For those values, if f dash of x is positive, then it is strictly increasing. If dash of x is negative, then it is strictly decreasing. For simply increasing, you have to take equals to. For simply, definition is said, you have to take equals to, and you can use the closed interval in place of open interval, closed interval. Simply increasing, the f dash of x is greater than or equals to 0 or less than or equals to 0, and interval should be taken closed A to B. Okay, box A to B. Closed interval means A to B. That is the difference between strictly increasing and decreasing. Same formula, but only greater than or f dash of x is greater than or equals to 0, and the interval x belongs to the closed interval. Square bracket A to B is to be taken. Let us take the problem in the next session. Okay.